Hello and welcome to today's class. For today's class, we'll be looking at the application of differentiation to minima, maxima, and curve sketching. All right, so we'll see how we can use the concept or the idea of differentiation to sketch curves. But before we go into curve sketching, let's consider two important things, which are minima and maxima. Now, how does this work? First things first, let me use some popular concepts to explain the meaning of minima and maxima. Now, if you can recall from the idea of quadratic equation, for a quadratic equation where I have that y is equal to ax squared plus bx plus c. So this is the general form of a quadratic equation. And we know that for an equation such as this, my graph would look like probably something of this nature. So I have this kind of curve. So we can say the curve of a quadratic equation is parabolic in shape. Also, if I have an equation such as y equal to minus ax squared plus bx plus c, for an equation such as this where I have a negative as the coefficient of x squared, for a curve of this nature here or of this kind of quadratic equation, I will have a curve such as this. All right, so this is like the major difference between the two different type of graphs of a quadratic equation, right? If the coefficient of x squared is positive, I will have a U-shaped curve like this, while if it is negative, I will have kind of like an inverted U or perhaps an N shape, please. So for this concept here, the lowest point of this curve is what is called a minima. So minima is simply the lowest point or the smallest part, right? The minimum part or point of a curve is called minima. While for a case like this, the highest point of a curve is called the maxima. All right. So when we talk about minima and maxima, we refer to the lowest point of a curve or the apex or the highest point of a curve respectively. So that's what is called minima and maxima. All right, so I have a case of this. All right, so having explained the concept of minima, maxima, we'll look at how to use the idea of minima, maxima to find or to sketch curves. So first things first, when it comes to minima, maxima, we've said that minima is the lowest point of a curve, while maxima refers to the highest point of a curve. Right. So when it comes to curve sketching or finding minima and maxima, there are two distinct ways of getting minima and maxima. The first method of getting minima and maxima, the first method is called the first derivative test. First derivative test. While the second method is called, because the first derivative test or first derivative method is called the second derivative all right, so these are like two methods of getting minima and maxima, right? The first derivative test and the second derivative test. So we'll pick each of them and see what they mean. All right, so let's start with our first derivative test. How does it work? All right, for first derivative test, please take note, please, that a turning point will be called a maximum if the 1 over dx is positive on the left hand side and negative on the right hand side. So for first derivative test, we said a turning point will be called maximum. So for maximum or maxima, the condition is that the y over the x will be positive on the left hand side and then negative on the right hand side. All right. So if the y over the x is positive on the left hand side and negative on the right hand side, it's a maxima. Also, note this is note number one. Note number two, that for a minima or minimum point, that dy over dx is negative on the left hand side and positive on the right hand side. Right, so this is the condition for a minimum point or a minima. Also, there's a third point called point of inflection. A third point called point of inflection. For point of inflection, dy over dx doesn't change sign. All right. So here are the three conditions I have to bear in mind while using first derivative test to calculate minima and maxima. We said for a maxima, dy over dx is positive on the left hand side and negative on the right hand side. For a minima, we have that dy over dx is negative on the left hand side and positive on the right hand side. While for a point of inflection, dy over dx does not change sign. All right, let's see how we can use this in solving problems. So example, find the turning point of y. So let's say y is equal to 2x cubed minus 9x squared plus 12x minus 4. All right, so let's say I have this question here. So the question is find the turning point of y equal to this and determine the nature of the curve. Right? By determining the nature of the curve, we mean perhaps if it's a minima, a maxima. So find the minima point, find the maxima point, and perhaps a point of inflection if possible. All right, so let's get this done, please. How do we solve this? To solve a question like this, your first task is this. All right, so if I have that y is equal to 2x cubed minus 9x squared plus 12x minus 4, to use my first derivative test, if I look at this, each of them contains dy dx, dy dx, dy dx. So my first task is to find the value of dy over dx. From here, I will have that dy over dx is equal to, if I differentiate it, this gives you 6x squared minus 2 times 9, that's 18x plus, if I differentiate this, I have 12. So I have my dy over dx as this value here. Now, there's a critical thing about this topic. There's something called a turning point. If you look at this graph here, these two graphs here, observe that before I have my minima and maxima, observe that this curve kept going upwards at a slanted angle until it got to a point where this stopped here. At this point, the curve stopped going upwards, then started descending downwards. In other words, for here, if I should get the slope of this curve here, my slope would be draw a tangent to this line here, that's this, such that I will now take a slope of this. Of course, here's my x-axis and here's my y-axis, such that the slope of this becomes dy all over dx. In other words, this one here, as I keep moving up this graph here, I will have that dy over dx is increasing. It keeps increasing on the point where dy over dx becomes 0. That means it stops increasing and then it starts descending or decreasing. Same thing happens here. If I should take the slope of this like this, and I take the slope of this line here, of course, I draw a tangent to this, and I took the slope of the tangent, I will have a dy over dx value as the slope of this curve here, although it will be negative. But the idea here we are focusing on is that at the minimum point, dy over dx keeps decreasing until it gets to a minimum point. It stops decreasing and then it starts increasing again. So the idea here is that at turning point, dy over dx is equal to 0. This is a critical condition when it comes to looking for minima and maxima. So I'm saying at turning point, that dy over dx is equal to 0. So at a point where it turns to give you a minima or it turns downward to give you a maxima, what happens is that the change in y over change in x is equal to 0. If this is true, I have that dy over dx is equal to this. So I'll equate this to 0. Hence, I'll have 6x squared minus 18x plus 12 equal to 0. So I have a quadratic equation. Let's solve this equation. First things first, all of these are divisible by 6. So divide here by 6, divide here by 6, divide here by 6. Same thing here, 6. From here, this cancels this. I have x squared minus 6 here, 1, 6 here, 3. So I have 3x plus 6 here, 1, 6 here, 2. So plus 2 is equal to 0 by 6, I have 0. All right, so I have this. X squared minus 3x plus 2 equal to 0. I'm going to solve this one here to get the roots of this equation. From this now, using factorization method of quadratic equation, I'll drop a link to the video on quadratic equation in the description of this video. So just check the description. You'll see a link to a class on quadratic equation. All right. So for this, I'll look for two numbers such that if they add, they'll give you this, and if they multiply, they'll give you this. Those numbers are minus 2 and minus 1. So this becomes x minus 2 and x minus 1 equal to 0. If I pick up this one here, I have x minus 2 equal to 0, or pick up this one, I have x minus 1 equal to 0. All right, let's find the value of x from here. From here, I now have that x minus 2 equal to 0. Move this over here, I have that x is equal to 2, or we can still have this one here, that x minus 1 is equal to 0. Move this one over here, I'll have that x is equal to minus 1 comes and becomes 1. So therefore, x is equal to 2 or 1. So of these 2 points there, I'm going to say x equal to 1. Still same thing though. So I have this one, please. Of these 2 points here, one of them is a minima, while the other one is a maxima. So how do we know which of them is a minima and which of them is a maxima? What do we do? First things first, there is something important I want to stress here, and that's this fact. If I have a coordinate system like this, any point on a coordinate system usually have 2 coordinates. So if I pick any point here, let's say I pick this point here, this point will have an x coordinate, and this point will also have a y coordinate, right? So any point on a Cartesian coordinate will have both an x value and a y value. This means that if I have these 2 x values as 2 or 1, I have to look for the corresponding y values of these 2. So how do I find that? I'll put x being equal to 2 and put x equal to 1 into this equation. So into y being equal to 2x cubed minus 9x squared plus 12x minus 4. All right, let's put x as 2 and find the value of y. Let's also put x as 1 and also find the corresponding value of y. All right, so I'll divide this way. All right, so at x equal to 2, what's y? Y will be equal to 2 into 2 cubed. That becomes 2 cubed minus 9 into x squared. That's 2 squared plus 12 into x, 2, then minus 4. Put a space for that. Then minus 4. So I have this. Also, at x equal to 1, what's y? Y is equal to 2 into x, that's 2 cubed, minus 9 into x squared. Sorry, here x is 1. So at x equal to 1, I have that y is equal to 2 into x cubed. X is 1, so it becomes 1 cubed minus 9 into x squared. X is 1, it becomes 1 squared plus 12 into x. X is 1 minus 4. I have this. All right, let's get this done. So from here, y is equal to 2 into 2 cubed is 8 minus 9 into 2 squared is 4 plus 12 times 2, 24 minus 4. From here, y is equal to, so that becomes 2 into 8 minus 9 into 4 plus 24 minus 20. That's about 0. So y is 0. This means that for this point here, when x is 2, y is 0. Don't forget, when it comes to coordinates, we write the x coordinate before the y. So when x is 2, y is 0. Let's get for this one here. So y is equal to 2 into 1 cubed is 1 minus 9 into 1 squared is 1 plus 12 times 1 is 12 minus 4. So y is equal to 2 minus 9 plus 12 minus 4. That's about 1. That is when x is 1, comma, y is 1. All right, so I have these two coordinates, this and this. Of these two, one of them is a minima and the other one is a maxima. So how do I find which of them is a minima and which of them is a maxima? What we'll do is very simple. We'll use the first derivative test and get our answer. All right, so we had 2 points there. Let me call them point A. Point A was 2, 0, and we also have point B. Point B is 1 and 1. So we had these two equations, this and this. From here, let's recall dy over dx equation. We said dy over dx is equal to 6x squared minus 18x plus 12 equal to 0. Now we said something about dy over dx being positive at the left hand side and negative at the right hand side, and we said that's a maxima. Now what does the left hand side, right hand side, left hand side, right hand side concept mean? What does it mean? So here's how to get your left hand side and right hand side. Let me pick my first point. If I pick my first point is A. A is 2 and 0. For this one here, I'm only considering the x-axis. So I'm ignoring y-axis. So I'm only considering x-axis. If I draw my line this way here, all right. So from I have Cartesian coordinates. Perhaps I can add 0, 1, 2, 3, and it continues. The concept of left-hand side and right-hand side simply means I'm taking 0.5 distance to my left and 0.5 distance to my right. That's all. So take half. Take a 0.5 distance to the left and 0.5 distance to the right. That's all about it. So if that's so, the point here is 2. If I take 0.5 to the left, this value becomes what there? 1.5. That means at this point here, 1.5 is about what there? 3 over 2 in fraction. But no problem. Let's use 1.5 because I have 1.52. This is my left hand side. For 2, move 0.5 to the right hand side. If I move to the right hand side 0.5, I will have here as 2.5 before 3. So I have this value. That means for 2 now, to my left hand side, I have 1.5. To my right hand side, I have 2.5. So let's look at, let's put these values into dy over dx. So at left hand side, I have that dy over dx is equal to, for this one here, left hand side is 1.5. All right, so I'll put 1.5 as x into this equation. So it becomes 6 into 1.5 squared minus 18 into 1.5 plus 12. So let's punch this value and see what we get. So we'll have that dy over dx is equal to 6 into 1.5 all squared minus 18 into 1.5 plus 12. That's about minus 1.5. That's minus 1.5. So observe that at the left-hand side, the y over the x is negative. Let's try right-hand side. So at right-hand side, what do we have? We have that dy over dx is equal to, at right hand side, you can see that value is now 2.5. So put 2.5 as x into this. It becomes 6 into x becomes 2.5 all squared minus 18 into x becomes 2.5 plus 12. All right, let's solve this. From here, I'll have that dy all over dx is equal to 6 into 2.5 squared plus this into 2.5. That gives me 4.5. 4.5. So what do we observe? Observe that at this point, 2, to my left-hand side, we had that dy over dx was negative to the left-hand side. To the right-hand side, we have that dy over dx was positive or is positive to the right-hand side. So if this condition is here, this point now becomes, is it a minima or a maxima? It becomes a minima, because we said for a minima, dy over dx is negative on the left-hand side and positive on the right-hand side. So therefore, the coordinates that's 2, 0 is a minima. It's a minima or minimum point. So that's this about this. So we've gotten this one. We've seen that this one here is a minima. Let's now find for this if it's a maxima or perhaps a point of inflection. So we'll do exactly the same thing here, but then I'll pick up this point. All right, so let me change some few things here. So let's take at B. At B is 1, 1. So for this one again, we'll do the same thing here. We'll consider just x-axis. The x-axis here is 1. So I have, let's say, 0, 1, 2, perhaps if you want to, 3. So we're using the same concept of taking 0.5 to the left and then 1.5 to the right. My point in this case now is 1. If I take 0.5 to the left this way, here would be about 0.5 because I have 0.51. This becomes the left hand side of 1. Let's now take 0.5 to the right. From here, add a 0.5 here. So if I move this way here, I'll be having 1. If I move 0.5 this way, I'll have 1.5. This becomes the right hand side. All right, so 0, 0.5, 1, 1.5, 2. So the only thing I did here was to move 0.5 to the left and then 0.5 to the right. All right, let's substitute this condition into a dy dx equation. So at left hand side, I have that dy over dx is equal to, so for left hand side, I have 0.5. I'll put 0.5 as x in the dy over dx equation. So it becomes 6 into 0.5 squared minus 18 into x. Said x, left hand side, x is 0.5 plus 12. So let's solve this. From here, we'll have that dy over dx is equal to 6 into 0.5 squared and minus 18 into 0.5 plus 12. That gives me 4.5. Okay, let's now try right hand side. So at right hand side. So at right hand side, what do I have? I'll have that dy over dx is equal to becomes 6 into this becomes 1.5 all squared, that's 1.5 minus 18 into 1.5, that's x plus 12. If I solve this here, it becomes 6 into 1.5, 18 into 1.5. That gives me minus 1.5 as my answer. So what do you observe? 4.1 here, which is 1, 1. The left-hand side is positive. You can see positive 4.5, while the right-hand side is negative. So when the y over the x is positive at the left and negative at the right, that gives you what there? A maxima. So therefore, the coordinate 1, 1 is a maxima. So we call it a maxima or maximum point. Maximum point. Same thing. All right, so we've established two things here. We've established that 2, 0 is a minima and 1, 1 is a maxima. So this is how we find minima and maxima of any function. So that's it. All right, let's see how we apply this into curve sketching. All right, so we established two facts here. The first fact was that A being 2, 0 is a relative minima, while B being 1, 1 is a maxima. So this is how we calculate minima and maxima. But how does this apply to helping us sketch curves? Right, so let's see how we can sketch curves using this concept. The first thing here is to recall your equation. So my equation there, I was given that y is equal to what? 2x cubed minus 9x squared plus 12x minus 4. So I have this. So when it comes to doing your curve sketching, there are two aspects to it. The first aspect is looking for your minima and maxima, which we've done. Your second aspect is to look for the roots of the equation. By the roots of the equation, we simply mean the point where the curve cuts the x-axis. So those are your roots of the equation. For us to find the root of any equation, we would equate it to 0, right? So it means to get the root of this equation here, I will equate this one here to 0. So it means that 2x cubed minus 9x squared plus 12x minus 4 is equal to 0. Please do not confuse getting root and turning point. Turning point is used to find minima and maxima. And I said for turning point, it is dy over dx that is equal to 0. That one is used to find minima and maxima. The second concept is looking for the root of the equation. For root of the equation, it is now y that's equal to 0. So I'm saying at this point here, we'll say let y be equal to 0. If y is equal to 0, that means this one here is equal to 0. So let's solve this equation. How do we solve this? We can choose to divide through by 2. I could simply use my calculator to punch this. I'll leave a video on how to do this one here using a calculator in the description of this video. All right, so I'll just simply go to using my calculator to solve this. So check the description of this video. You'll see how to use calculator to solve this. All right, so let me work the Casio FX991 MS Plus calculator. Here A is 2, B is minus 9, C is plus 12, D is minus 4, and that's equal to, so we have that from here, I have that um, one of my factors here is 2x minus 1. The other factor here is x minus 2. The third factor here is x minus 2. I'll show you how I got this using a calculator in the description of this video. So just simply check the description of this video. You'll see how I got this. All right. Okay. This is how to show working on how I got this. Is this simple? So I'll be very fast with this. So here's how this is done. So if I take, I said if I take 2x cubed minus 9x squared plus 12x minus 4 equal to 0. If I put x as 1 here, this will not give you 0. So you can try that. Now put x as 2. It becomes 2 into 2 cubed minus 9 into 2 squared plus 12 into 2 minus 4. If you solve this, all of this will be equal to 0. So it means that x equal to 2 is a factor of this polynomial. From here, I will get an expression. How do I get the expression? Move 2 over here. I'll now have x minus 2. This is how we find our first factor, x minus 2. So it's simply a testing. You test with 1. If 1 does not work, you can test with minus 1. Minus 1 also. If I put here as minus 1, you won't get 0. You can try that on your own. Put x as 2. You can now get 0. So if x is equal to 2, move 2 over here becomes x minus 2, and you have this. All right, so x minus 2 is now a factor. If this is so, my next task will now be divide this equation by x minus 2. So that gives you 2x cubed minus 9x squared plus 12x minus 4 equal to 0. Okay, leave this out for now. Divide this by the factor we've got. My factor here is x minus 2. Let me take this off to create space. All right, so dividing this, divide this by this, divide just the first terms. My first term here is 2x cubed. Divide this by x. From here, x here 1, x here x squared. That becomes 2x squared. So if I bring 2x squared here, 2x squared times x gives you 2x cubed. 2x squared times minus 2 gives you minus 4x squared. Do your subtraction. If I subtract this, 2x cubed minus 2x cubed gives you 0. It's off. I now have minus 9x squared minus 4x squared. Minus 4 gives you plus 4. Minus 9 plus 4 is minus 5x squared. Bring this down, plus 12x. Bring this down, minus 4. I have this. My next task will now be still divide this first term here by the first term here. So it becomes minus 5x squared divided by x. From here, x here 1, x here x, minus 5 times x is minus 5x. Minus 5x times x gives you minus 5x squared. Minus times minus plus 5x times 2 gives you 10x. So I have this. Subtract this. Minus 5x squared minus 5x squared. Minus is plus. So I have minus 5 plus 5 gives you what there? 0. It's off. I'm now left with 12 minus plus 10. Minus plus is minus. 12 minus 10 is 2x. Bring down minus 4. The power here is 1. The power here is 1. The power of x here is 1. The power of x here is 1. So for the fact that the power of x here are still the same, I can still proceed to divide. If I divide once more, I have 2x, that's this, divided by what I have here, that's x. So x cancels x, I'm left with plus 2. It becomes plus 2. 2 times x gives you 2x. 2 times minus 2 gives you minus 4. if I look at this critically, they are the same thing. And if the same number subtract, it will give you what there? 0. And this was why this is a factor. So on solving this, I now have this quadratic equation. You now pick up this quadratic equation, 2x squared minus 5x plus 2. Solve this as a quadratic equation. You have your roots as x, excuse me, 2x minus 1 and then x minus 2. You have this. So this 2 now becomes your final root. So this is how we can find this manually. All right. It's quite a lengthy process, but get the idea. You start by testing. Right. Test x equal to 1. That will not give you 0. Put x as minus 1. You still won't get 0. Put x as 2 into this equation. You now get 0. So if x is equal to 2, move 2 over here. You now have that x plus 2 comes and becomes minus 2. So you have x minus 2 as a factor. Use this to divide this cubic equation. You have a quadratic equation such that if I factorize the quadratic equation here, I'll now have this. You now have your other roots. It becomes 1, 2, and 3. That's how you can manually find this. All right. Let's proceed with this, please. So let's get the value of x here. From here, this one here, let me do it this way. So if 2x minus 1, of course, this is equal to 0. So if 2x minus 1 is equal to 0, pick up this one here. From here, 2x is equal to minus 1 comes and becomes plus 1. Divide here by 2, divide here by 2. This cancels this. So x is equal to 1 over 2. Here, you have x minus 2 is equal to 0. Move this over here. You have that x is equal to plus 2. Here, you have that x minus 2 is equal to 0. Move this over here. You have that x is equal to 2. So the roots of the equation are 1 over 2. That's half. 2 and then 2. All right. So having found our roots, having found our minima and maxima, let's now go ahead to sketch the curve. All right, so from this, if I look at my points very well, I have half. This is positive, positive, positive. That means I'm not working with the negative region. So that means I'll move this somewhere here, and then I'll draw my line, perhaps this way. All right. So I'm drawing it this way because I do not have any negative values. So I know I'm working with just positive only. All right. So let's get, we need half, we need 2, we need 2. So here's 0. Let's call this 1. Let's call this 2. Let's just add one more point there. Call somewhere here 3. All right, let's get our first point, the minima point. The minima is 2 and 0. It means when x is 2, y is 0. When x is 2, y is 0. That should be this point here. Because here's my x-axis. So here's the x-axis. Here's the y-axis. So when x is 2, y is 0. That's this point here. So this is my minima. Let's get maxima. Maxima, when x is 1, y is 1. Let's get 1 for y. Let's call this 1. Let's call this 2. So when x is 1, y is 1. That should be, this is y being 1. This is x being 1. They meet at this point. So here becomes my maxima. Here becomes my minima. All right. So what next there? Let's look at the turning points. Let's look at the roots, please. The roots. These 2 points are my turning points, my maxima and my minima. Let's look at the roots. The roots is simply where the curve crosses the x-axis. This one is saying that the curve crosses the x-axis at x equal to half. At half. So that's 1 over 2. This is 0. 1 over 2 should be here. That's midway between 0 and 1. I'll have 1 over 2. So this says that the curve cuts the x-axis at this point, that's half, which is this point here, which I've got. The next task here says the curve cuts the x-axis at 2, which is coincidentally the same point here. What does it mean? It means that this curve goes from here. If it cuts the curve at this point and this point, and I have here as a maximum, that means it has to, from here, it has to go up here to my maximum, come down here like this. So for this now, before we explain something, let me show you something you should know. Note this. Let me teach you about graphs a bit. Note that for a linear graph, we have that y is equal to mx plus c. This will give you a straight line graph. I have this. The second one, note that for y equal to ax squared plus bx plus c. This is quadratic. For this, I will have a graph of this nature. And then for something of this, y equal to ax cubed plus bx squared plus cx plus d, my graph should look like something of, perhaps something like this, something of this nature. So here's the idea I'm trying to give. For a straight line graph like this, you have a straight line. For a quadratic equation or quadratic graph, I'll have 2 points here. Let me relate this to this cutting the x-axis, perhaps. So I'll have something, okay, so I have this. So for a quadratic equation, I'll have just one curve. I think that's the idea I'm trying to send. For a quadratic equation, I'll have just one curve. Why for a cubic equation, I'll have 2 curves, right? When the part here is 1, there is no curve. It's a straight line. When the part here, or the highest part of x here is 2, I'll have just one curve. That's one turning point per se. When the highest power of the variable or x is 3 here, I'll have 2 curves. So it's more like saying the number of curves is equal to the highest power minus 1. That's the idea. Right, so I'll have 2 turning points. In other words, for this one here, if I observe, this equation is to power 3. That means I should have what there? 2 turning points, which are what there? The maxima and minima. So this one gives you a picture of what to expect. If I should relate this to this, it means this will go like this to the maximum point and then come down to what there? The minimum point, just like this. So it should take this shape. That's the idea. All right. So from here, half, it cuts at half and 2. That means from here, since this is my maxima, I'll go up to this. So I'm having this one here. Let me see if I can get this. This is done. This come here. This like this, like this, like this, this. So I'm trying to do a sketch so I can have a fine graph. All right. Let's see how this goes. Going upward, touches here, goes to maxima, touches maxima, please. As my maxima, it starts coming down again, as we said. Goes down up to my minima, which is this point here. Also cuts the x-axis here. From minima, starts going up again. So I have this. All right. So this becomes the core of the graph. Don't forget, this point is my maxima. Maxima was 1, 1. This point here is my minima. Minima was 2, 0. So I have this. So this is how we can sketch curves and also find maxima and minima using the concept of differentiation. All right, so this is for the first derivative test. In our next class, we'll see how to use second derivative test.